Greetings, Woodians and School of Lifers. This week, I'm gonna talk about how the practice of business analysis overlaps with many other practices in management analysis and other areas. I've been doing simulation my whole career, both major families, continuous, which is based on differential equations, which tend to have consistent time steps, and then discrete event simulation, which has arbitrary time steps, and it's mostly concerned with logical events. I've done this in many industries for many applications in many different architectures. By the way, the slides are presented in the reveal.js framework. They're hosted directly on my website, and there are a lot of embedded links that go to other materials, so feel free to check those out. So if we're going to compare a bunch of different practices to business analysis, we first ought to talk about what business analysis itself is. Now, I've been talking about this for the last 10 weeks, so if you've been following this series, or if you have experience in the field, you already know. But for purposes of this, I'll give you the briefest of rundowns so we have a place to start. So this is on the word, figure out the problem, what it is, figure out how we're going to handle different parts that we know and don't know, what it's going to do, figure out what's going on now and some of the components we're going to need for the solution if we already have some idea of what that is. Deal with data having to do with what we'll need and what we're doing now. Functional and non-functional requirements, which is an abstract form of the to-be state. One or more designs from which you choose one to pursue, and that's a detailed form of the to-be state. Then you actually do it, you implement it, then you test it. And then if the testing all goes well, if the verification and validation all passes, then you do some sort of accreditation or not. And then that work is all wrapped in a project management wrapper. So there's a lot of potential overlap between business analysis and project management. So if we look at all these areas I just listed, and we look at the major knowledge areas in the BABOK, and the BABOK is the business analysis body of knowledge. It's a big orange book, currently in its 3rd edition. It's kind of the little brother to the PMBOK, which is the same word for project management. And it tells the same story in a different way. And I think the way I actually present this makes more sense and flows better than what the BABOK shows. which is not to say that the backlog doesn't have a lot of great information in it, because it does. But anyway, if you look at it, the major overlaps tend to go from the upper left to the lower right as you work through a project this way and this way. And there, it shows that we're pretty much telling the same story. So if we streamline and stylize the framework or the steps, we're gonna get something that looks like this. Again, this is for business analysis. And then in the end, we're gonna pack it up and show it like this. So figure out what the problem is, what we're trying to accomplish, figure out what's going on now in the pieces of the solution, potentially figure out what we need, discover or devise a plan of attack, go ahead and attack, and then test, verify, and validate. And the reason I show it this way is that whoever's doing the work, the analytical and solution team or whatever, they iterate with the customer, be that internal or external, in every phase to make sure everything is understood completely and accurately. And you can also iterate between phases. So the classic way to understand this is that you iterate between implementation and test. You build something to test it. If it's not right, you send it back to implementation to modify or do something different. So you actually do that between all these phases. And the reason that works is because it's essentially the scientific method, right? You come up with a hypothesis, you propose something, then you gather data and do experiments, then you test against the hypothesis and either confirm or move forward, or you go back and try again. So everything is always iterative. And of course, that works pretty well, right? So business analysis is about solving the problem, but mostly the process of solving the problem based on what the customer actually needs. So just for clarification, I use a few words. The engagement is the work we do, the process of solving the problem with the customer as a team. And then the system, which could be the process under investigation or product or an environment. That's what we analyze and either build or change to serve customers. And the solution is the actual change, whether it's a modification or a creation from scratch. The backlog lists 50 specific techniques. In my weekly IIBA study groups, we are currently going through these one by one and talking about whether they are most germane to the solution or the engagement or both. I've learned some things by talking to various practitioners, And I think a couple of these items are in the process of being updated. This is just my own feeling, but the point is that a lot of these specific techniques show up in a lot of practice areas that I'm going to discuss. For example, root cause analysis happens everywhere. Use cases, a lot of places, user stories. So there are a lot of techniques that show up in many different practice areas. What we want to do is figure out the overall is of each practice area, what it's really about. So let's list a bunch of them that we're going to talk about. So obviously we're starting with business analysis, and there are a number of certifications that are issued by a number of certifying bodies. There's also project management, and then there's Agile and Scrum, and there are a ton of these. The ones in red are primarily by the Scrum Alliance. The ones in yellow are by scrum.org. The ones in green are by the IIBA. And the ones in light blue here are led by PMI. We also have process improvements. You've heard of all the Six Sigma stuff and Lean. There's also total quality management, stemming the Toyota production system, and so on. There have certifications, and there's a growing practice in data analysis. Basically, data used to be called big data, but now it's just data. Everything AI, everything is eating the world. Cybersecurity is always important. And system architecture is another major practice. There are certifications, documentation standards in different industries. For example, a lot of big government work, particularly for the military, uses TOGAF, but a lot of people use it. BPMN is not a certification, it is a way of doing drawings. It's a notation that's kind of standard. ITIL is both a certification and a framework for doing things. And then every single vendor or product has its own potential certifications and training and bodies of knowledge and so on. So if we list all those in a grid by certifying organization and certification and practice area, these are the ones I'm going to compare and contrast. Here in the leftmost column, that shows how they all lay out. So let's start with some general commentary. All these practice areas are meant to solve problems, and like I said, there's a lot of overlap. Same thing. So I just spent 90 hours in the last couple of years renewing my certifications in Agile and Scrum. 42 years ago and 50, I just finished with my latest renewal cycle. And they talk about a lot of different concepts, but that isn't really what Agile is about. And what it really is get people to talk to each other. Almost everything you talk about in those fields is about that. And I'll have more to say on that in a minute. In project management, they list a lot of things I talked about, but a lot of these practices don't tell you how to do them. They just say that you need to do them. So they're really talking about a higher level with a different emphasis, each one. So when a different organization presents information in multiple areas, they tend to approach it the same way. So the IIBA talks about business analysis. Now, the PMI, which is the Project Management Institute, does the same thing, but they do it a different way. But the IIBA talks about business analysis in a way that a couple of slides ago I drew in similar to this. However, this particular approach is for their data analysis certification and the way they recommend doing things. So there are 5 steps instead of 6, or their 5 knowledge areas are: identify research questions, source data, analyze that data, interpret and report results, and then use results in business to make decisions. So that's pretty much like figure out what you need to do, figure out what's going on now, figure out what people need, do some sort of design or implementation, and then implement. So it's basically the same approach, but it's with a different emphasis and a different raw material, even though there's a lot of overlap. So let's talk about project management. If you're familiar with the material in the PMBOK, the project management deals with these 10 areas. So it's mostly resources, iron triangle type stuff, communication, risk, and that kind of thing. And they're all different aspects of the same thing. So you get started, you plan, you acquire and organize everything. Then you do the work, then you monitor and control it, then you close it. So again, we have an approach that works through time across a number of different concerns. And there's a lot of ways we can run projects, a lot of different practice areas kind of overlap with many different approaches. Agile and Scrum are mostly about this kind of approach, but in the end, nobody even does waterfall in a truly waterfall way. There's always iteration and communication. It's just a question of whether you do it well or poorly. These days, the biggest thing that drives waterfall is how much you know going in about what you want to accomplish. And agile methods are more geared toward kind of figuring out as you go. So, like the project management group says, plan the work, do the work, monitor and control the work, and close the work. And there's a famous quote, tell them what you're going to say, and then tell them what you said. So that was by Dale Carnegie. Will Smith has an interesting scene where he says this in a movie. So I'd like to liken those two to each other. So let's talk about project management. It was originally developed with an eye toward doing things in a professional, organized, waterfall methodology, but good managers have always incorporated feedback, correction, and adaptability. So the article I linked to here is something I wrote, which actually involves a couple of articles. And those even refer to the way that Leonardo da Vinci and Michelangelo actually worked in an iterative fashion to figure out what's going on. Leonardo did a lot of iteration to create layers and to make things better and improve and redo and revisit things more completely and fully. And then Michelangelo's big add to that, he did the same thing, was he scaled it. So he had a lot of apprentices and so on that he taught how to do the work, allowed them to do the work within his framework, and he got a huge amount done. So the other practice areas tend not to talk about resources, but you know that somebody is. So project management definitely does that. I've actually seen a few and blogged about a few different presentations I've seen that talk about building teams. And there was some interpersonal, hey, handle problems and manage teams in my Lean Six Sigma coursework, but that's not the major emphasis. But it's definitely an emphasis of project management. And like I've said before, business analysis is an activity that takes place within a project management wrapper. And these are the 6 phases that business analysts work through. And really, the red phase overlaps with the whole beginning stuff. The senior BAs in the PM should work hand in hand across all this stuff. The more all the practitioners in each area understand each other's work, as in every case, the better off everybody is going to be. So let's talk about Agile and Scrum. Scrum is often depicted like this. In my framework, it's basically like this. So it takes these 6 basic activities and it lays them out the way Scrum is usually done. There's a lot more to it than this. The Wikipedia entries for those areas link to a zillion different frameworks and other ways to do and think about things. So Agile grew out of the state of the industry as it existed in the late 90s, and it was meant to address the way things were understood then. And now, even the people who have written that stuff, who created this approach, have kind of moved beyond it, and they've gotten to the point I've gotten to, which is it's really all about talking to each other and making corrections as you go. So you're always trying to be flexible and adaptive. Now, if you're going to study Agile and Scrum and get a basic certification, that's great. It's a place to start, but you have to understand that if you think you can do it out of a book by rote, step by step, the way somebody else says, you're not doing it right. You have to start someplace when you don't know that much. But in the end, you really have to learn the underlying theory and practice so you can apply it flexibly. Agile and Scrum are really ways of pushing decision making and autonomy down to a lower level of the organization and making organizations flatter, more independent, and more responsive. And there are a lot of ways people have done this. What you always want to do is allow people who have local and specific knowledge to be able to apply in the best possible ways. And that doesn't mean you don't need higher levels of awareness and strategy, but there has to be a happy medium. So Agile and Scrum are basically, if you think about it, they're taking over the world. At least they might have been thought about that way a few years ago. Now everybody is all hot for ChatGPT and pseudo AI type stuff. But there's always a different fad, and everybody still thinks in terms of Agile is everything, even if they don't quite understand what it's all about. So many practices and techniques can be very general. So a lot of the stuff that's in the training materials that I got really came out of extreme programming. And then part that was actually Scrum and Agile was almost mindlessly simple. But you have to wallow around in the material to really understand the underlying context a bit. So let's ask a couple of questions. Is test-driven development really part of Scrum? I say no. Although there's Scrum has a developer track. So that it makes sense to talk about more of the extreme programming and the technical stuff. The other main tracks are the Scrum Master track, which is getting the team to use Scrum methodology, and the product owner track, which is essentially a BA role, which is making sure people are doing work that addresses things the organization actually needs. And the big question about all these is how much of it is actually good knowledge and how much is just cruft that supports a cottage industry of training and certification and consultants and so on. There's a place for everything. And the question is, how much of each should you actually have? Another thing they talk about in extreme programming and in Agile and Scrum is something called a horizontal versus vertical slicing. And this irritates me in particular because the general way they tell you to approach something is horizontal slicing, and don't ever do no, you should do vertical slicing and generally shouldn't do horizontal. But because of specific work I've done building tools to automate things and building tools that build other tools, sometimes you do horizontal slicing. That's what you need to do. So for every rule people give you, there's probably an exception to it. And again, if you're doing it by the book as it's written and treat that as holy writ, you're probably doing it wrong. It's always good to understand the spirit and the practice of what is presented. So the vast majority of Scrum certs are lowest level, and that's probably the way it should be. Scrum Masters are the predominant one. There are fewer product owners and even fewer developers and trainers and other things. And most people only get the basics. They don't pursue it too much further. So unless a Scrum Master is supporting individual teams, in my opinion, having a full-time Scrum Master is generally too much effort and resources to devote to just running Scrum. That person should be one other kind of subject matter expert who's doing the work, and by the way, also happens to know the Scrum move and keep people on track and know how to do things. So if the whole certification industry disappeared tomorrow, I wouldn't miss it. It doesn't really cover anything that's not in the other practice areas, with one exception. It does get people talking to each other. So at the end of the day, that's what it's all about. And it took people about 15 years to figure this out. So let's move on to process improvement. One of the biggest things we talk about in this area is Lean Six Sigma. And there are actually two sides of the same coin. Lean is about doing more with less, so it's about efficiency. And Six Sigma is really about reducing variation. And if you reduce variation, you get fewer things out of spec and that will reduce errors, waste, rework, and so on. And that leads to quality. Lean is more of an art. There aren't really a bunch of hardcore specific techniques you can use to do lean. There are some guidelines, and Six Sigma is more about the math and more about specific approaches in many cases, but not always. Total quality management, that was big in the 90s. There was a book by Crosby called Quality is Free, and really said that quality is defined by reaching the standards that you set. So what you want to do is define standards and then meet them. Deming was huge in this. Going back to the middle of the last century, he did a lot of work in Japan, and that's why the Japanese are really big on quality and iteration and continuous improvement. Deming, and all the reading I've done about him and the training I've done, I didn't know about his system of profound knowledge until more recently. So that's interesting. There's always more to learn. And there are a lot of different ways to do all these things. I mentioned previously the Toyota production system, and it's really all about just always improving and learning. So here are a few things about process improvement. It's not only after the fact, it's also proactive. So within the last couple of weeks, I wrote a blog post and shared it with my IIBA study group on Thursday evenings about root cause analysis. And that can be both reactive, which means figure out what went wrong after it happened, and then prevent things from going wrong before they happen. So that is proactive. And one major way to do proactive root cause analysis is called FMEA, which is failure modes evaluation and analysis, or something very close to that. And it says that you want to look at every component and interface and linkage in a system, figure out all the ways it could break, and have spares and have ways to recover from those in the way that makes the most sense. And we were always taught that the shuttle system, which is pretty extensive at the Dallas-Fort Worth Airport, was designed with that in mind. So process improvement is should be an integral part of the design process, as well as something you do once you've created the process. There are a lot of iterative methodologies. Some of these I learned from military. Some I learned from my Lean Six Sigma black belt training. PDCA is planned to check act. I can't remember domain, Una comes from the military, and I always think about that as something you do in a stressful situation like in combat, and it's observe, orient, do and adapt, something like that. So there are all ways of iteratively figuring out what's going on and adapting to it and taking effective action. The Lean Six Sigma Black Belt training was by far the most extensive. It required the most effort and time, and I learned by far the most material. Everything else was comparatively easy. And one of the things Six Sigma talks about is the voice of the customer and the voice of the process. And to some degree, that is what the customer's needs are and what the process needs are, or the system, or the product. And there's a lot of overlap between these practice areas. Let's talk about data analysis. It's about the collection, conditioning, movement, transformation, integration, storage, retrieval, documentation, analysis, safeguarding, display, communication, management, leveraging, and utilization of data. It's both qualitative, which means the nouns and verbs of what's going on, and it's quantitative, which is the adjectives and adverbs that quantify or characterize everything learned in discovery. So activities associated with data include these things. AI is big, simulation is big, and applications or optimization, design, trends analysis, economics analysis, demographics, process control, and so on. Now let's talk about cybersecurity. I'm not an expert in this. Of all these practice areas, this is the only one I've never directly worked in. However, we know a few things. We know it's critically important. This is another big area that's out current right now. We need to know how to talk to experts in it to incorporate their advice into our systems and designs and operations, how to incorporate their solutions in other work, and how their work involves software, hardware, people, and integrations or organization. So if we look at a little notional systems here, so we have a remote system, some sort of communications going on between systems, some sort of local system, a local user that's part of an organization. We see that within and between all of these entities, we have to worry about security, and the nature of the concerns are a little bit different in each case. And you have to be aware of and address all these cases to come up with a solid cyberly secure system. Now let's talk about system architecture. And this is a way we describe how systems are built. We can use any notation or methodology that is appropriate for the industry. One of the things I learned fairly recently from a guest speaker, and this was a piece I was looking for a long time, that really clarified in my mind how even my framework works, is that designs tend to include 3 layers. So there's the logical layer of what you actually do. There's a business layer, which involves organizations and people and departments and functions and so on. And there's the technology layer, which could also be, because it's not always about technology, call it more generally the hosting or implementation layer. So you have to understand all 3 and get those things working. I tend to think about solving problems from the point of view of defining the application layer and working outwards, both up and down from there. And because I've worked in so many different industries, I've created a ton of different designs and specifications and drawings and documentation that describe a wide variety of systems. And there are many different ways to write them. There are all kinds of standards. And there are many ways to even describe a similar system. So if we look at this is a P&ID of a paper mill or process and instrumentation diagram. And it shows the logical flow of material and energy and signals through a system and the various pieces of equipment. But a layout drawing would show where the floors are, where the pipes go, how big they are, all the levels that go up and down, the geometry, the materials, and so on. And it's talking about the exact same system, but it's talking about it from a totally different point of view, and you need all of them working together to have a complete understanding. Again, this is what UML does for system design. So it's a way of looking at all the aspects of a system from different points of view, and depending on the kind of system you're designing, you'll tend to do that differently. So every practice area has a different way of breaking things down. Business analysis, you would discover what's going on and what the requirements are. So that's the way to think about it. The project management, you do a work breakdown structure. It would decompose things into smaller and smaller components, so you can get the resources needed to address them in whatever way they require. Agile and Scrum are about backlog development and grooming a lot of what we talk about in Agile, especially as a Scrum Master, is about taking items out of the backlog and working them as a team. Overall, the practice does not have nearly as much to say about the work of identifying items that are supposed to go into the backlog. So I find that interesting. Business analysis really covers the full life cycle, I think, in a more complete way. Process improvement talks about identifying the problem, doing root cause analysis, FMEA, fishbone diagrams. Those are parts of it. But you're always having to understand all aspects of the system so you know what to change or build in a way, it has a huge amount of overlap with the way I think about business analysis. I really came to business analysis after having done all these other things. So it's natural for me to think about it this way. For data analysis, you have to understand all the data items, and there's a lot of techniques about what you can do with data once you have it. And a lot of what's going on in modern management across all these fields is learning how to manage greater volume in complexity. That's what's going on. For cybersecurity, you have to be aware of all parts of the system and the interfaces between them, and you have to identify, understand, and secure them. And when you're talking about system architecture, you have to know what all the components are and how to make them work together at multiple levels. So let's talk more about functional decomposition. So like I talked about last week, here's a kind of hierarchical representation of a system. It is logical breakdown, and here is a way to trace all the elements of the work you do in a business and analysis, engagement through time over the course of the engagement. And here's how we might do the work in a safe environment. So if you look at this, we might have several teams working in synchronized sprints. Some teams may draw from a common backlog, some may draw from separate backlogs. We may have waterfall work going on at the same time, which won't necessarily match up with what's happening in the sprints. And you will also potentially have work going on in a continuous way, either using Kanban or triage or whatever. And it's really all about understanding those things, keeping them in sync, and that is accomplished by getting people to talk to each other. So there are a lot of different artifacts we may create to manage all this. We might do Gantt charts in Microsoft Project or even in Excel to keep track of this. It might not work for certain management environments, but it might work for others. If you have a Gantt chart, then you can have critical path analysis and identify the thing you need that's going to be the lower bounds of how fast you can get things done. And you can also analyze things from the point of view of a minimum viable product. And you can think about things in terms of releasable increments. So these are all the things you have to be aware of, all jumbled up together, but yet keep them straight in your mind when you're doing anything of any complexity. So getting near the end, there's a lot of specific information and techniques involved in all the different practice areas, and it generally makes sense, but you need to know what are the general techniques and what the overriding concern of the practice area is. And many sub-practices or individual techniques occur in many different bodies of knowledge. So I was reading a book. I think, sitting in Thailand while I was reading this. And doing work, I was there for 2 months putting a control system in a steel mill, and the work was done within a week, and I think I sat there for like 8 more weeks waiting to test it. And the book was by a guy named Pablo Soleri, who's a famous visionary architect. He was a student of Frank Lloyd Wright. One of the most famous things he's known for is Arco Santi, which is his experimental laboratory and city of the future that he's built out in the desert north of Phoenix. I've been there a few times. It's kind of a neat place on the one hand, and it's kind of sad and forlorn on the other. Anyways, I realized when I was reading the book that everybody, no matter what they're doing in life, always ends up trying to answer the same questions. What does it all mean? Why are we doing it? What's the best way to do it? And how do I work with other people? That's in the end the important thing. So business analysis is how we analyze and solve problems for internal and external customers based on their requirements. Project management is how to arrange and manage the actual work and resources to accomplish things. That's a wrapper around all the other practices. Agile and Scrum is about how to flatten organizations and teams and make them autonomous, and how to push decision making down to lower levels. Process improvement is how to make activities more consistent and less error prone and use fewer resources. So it is do more with less and do the same with more, something like that. Data analysis is how to use information in support of a lot of other activities. Cybersecurity is how to ensure systems and organizations safeguard data and processes. Its system architecture is about how to design and configure systems. And finally, we've reached the end. As always, this and other information can be found at my website. Thank you for paying attention to this.